So let's look at our final example here. This is an enhancement Pmos and it's discharging. So it's already charged up at 5 volts, and then what we're going to do is turn the device on, and when the device turns on it's going to discharge through to 0 volts. So let's look at the first section here. We've got 0 volts at this side here, we've got 5 volts on the gate, and we've got 5 volts on this side. So it's a Pmos device. The holes are the charge carriers. The charge carriers come from the positive terminal to the negative terminal, so this must be the source here, and this must be the drain. So again, we can put over here the source and the drain. So let's analyse this one here. The threshold voltage for a Pmos device is going to be -1 volt. The VGS minus VT, so there's VG, which is 5, and the VS is 5, so we're going to have 5 minus 5, which is 0, minus the VT. Well, the VT is -1, so it's -1, so that's 0 plus 1, which is a value of 1. So we've got VGS minus VT is greater than 0, and if that's the case, then it's in cut-off. So that is the case, because VGS minus VT is equal to a value of 1. We then go ahead and we change the voltage on the gate. So the gate goes from a 5 volts down to a 0 volts. So on a Pmos device, that's equivalent to turning it on. And then we'll go through the same equations again. We're going to have our V gate source. So the gate now is 0 volts, and the source voltage, well, we don't know what the source voltage is, so we're just going to have to keep it as Vs. So we're going to have 0 minus Vs, so the V gate source minus Vt is 0 minus the Vs, and the Vt, remember, is -1, so it's going to be minus the -1, which is +1. So that VGS minus Vt is minus Vs plus 1. So we've got to compare this with the VDS. Now the VDS is the VD minus the VS, so the VD is 0 minus the VS, and we don't know what that is, we'll leave it as VS, so we're going to have simply minus VS. So we're going to check and see the 3 possible regions of operation. So it's going to be in cut off if the VGS minus VT, which is this minus Vs plus 1, is greater than or equal to a value of 0. So if we take this across, that will become -1, so you have minus Vs is greater than or equal to -1, multiply throughout by the -1, and we'll get Vs is less than or equal to a value of 1. So remember, when you're multiplying an inequality with a -1, the sign is going to change. So that's going to be cut off then whenever the value of Vs is less than or equal to a value of 1. So let's look at the other 2 possibilities. If the VGS minus VT is less than or equal to VDS, so that's going to be minus Vs plus 1, is less than or equal to VDS. Now the VDS, remember, is minus Vs, so this is the equation here. So we could take this minus Vs across, becomes plus Vs, and that says it's in the linear region if 1 is less than or equal to 0. So 1 is not less than or equal to 0, so it is not in the linear region, so it never enters into the linear region. Now if we check the saturation region, again we're checking see whether VGS minus VT in this case is greater than or equal to VDS. So that's minus Vs plus 1, and again the VDS is going to be equal to just the minus Vs. So we're checking this equality here. So we can take this minus Vs across, and it becomes plus Vs minus Vs. That ends as a 0. So what we're saying is 1 is greater than or equal to 0. So 1 is greater than or 0 is greater than 0. So it is in the saturation region. So in summary then, what happens is that this device is going to discharge, and it's going to discharge in the saturation region from 5 volts all the way down to 1 volt. But as soon as it hits 1 volt, then the device is actually going to switch off. So we're going to get a threshold voltage drop again across this device. So it's not going to fully discharge. We're still going to be left with 1 volt here on this terminal. So again, let's have a look at it in the tool, the simulation tool, and it will become easier to understand. So if you head into the resources section and again click on the link to open up the simulation tool, then what we want to do is we want to make sure that we've got our VT is equal to -1, because -1 is going to be an enhancement Pmos device. Now what we want to do is put the actual values in. So we're going to start off with a value of 5 on the gate. So we'll put 5 on the gate here. And we're going to have a value of 5 on the source. So the source is going to have a value of 5. And the drain is sitting with a value of 0. So that's the initial starting position that we've seen in the example. So you can see here that the device is indeed off because there is no inversion layer. You see our line here is above the channel here, so the device is off. Now what we're going to do is we're going to turn the device on by changing the voltage level here at the gate to a value of 0. So we'll pop that in and make that a value of 0. So you can see that whenever we done that, the device is now turned on because there's an inversion layer here, and you can see here there's actually a saturation current. So the device is in saturation here, so there's a saturation current flowing. Now what's going to happen is the capacitor, which is now sitting on this source side here, is going to discharge through the transistor down to the drain, which is sitting at 0 volts. Now what's going to happen is whenever it discharges down through to 0 volts, it means that that source voltage is going to decrease. So we're going to lose the charge off of this, or the voltage off of this side. So it means that the drain the source voltage is going to start decreasing. So let's see what happens when that happens. So you can see that this voltage is starting to decrease, but we're still in the saturation region, so it's always saturated until eventually what happens is we get down to the Vs is equal to 1 volt, and at that point there you can see the device is now actually switched off. So we can't drop this voltage down any further than 1 volt because this device is now switched off, and that's exactly what we've seen whenever we looked at the equations. So this covers the 4 possible gates that we're interested in, and it has a good example of the pass transistors. So before we do anything else, we'll go ahead and we'll summarise what we've done over the last 4 videos. So thank you for listening. I'll get you on the next video. Goodbye.